So the SD9 is going back together, and I was just going to show you, here's the Kadee setups. So you've got these inserts that kind of fit into the pilots, into the fixed pilots. Here's one assembled before it goes back on the engine. So you can see the insert kind of bolts up into that empty space that allows for the 3-rail coupler to swing through. So pretty nice setup, probably one of the nicer scale coupler setups for a modern diesel product, I guess. Here's the plug for the 3-rail coupler. So Third Rail did a nice job making these adaptable to scale couplers without having to take the whole thing apart. There is a like pivot adapter or something here, and this comes off, and it looks like this. And then these 2mm screws can be used to go through these through holes, and that's what adapts it into the pilot here. So I think the Kadee heights are pretty good for a factory job. No shimming required. Looks pretty good, I think. So here's what they did for the controls and stuff. It's kind of nice. So I think we're almost ready to go give this a test drive. So here's the hatch with the exhausts and the dynamic braking grid, I guess. So of course I get everything back together, and I was looking at the engine and I'm like, hey, I remember mine had a nicely detailed and lit cab. And so sure enough, I look in there and I'm like, yeah, I remember this thing did have a cab light. So of course it's all back together, ready to go for a test run on the layout, and I realized the cab light is not working. It turns out the thing was just, I don't know, burnt out, or maybe the resistor's burnt out. I can't find the resistor now, but anyway, here's a new one, and I put a diode and another 1K resistor in series with it. These are just another eBay LED, just to tone it down and to give it a little reverse bias protection, I suppose. So anyway, it's gonna go up in here, and I'll put a little goo on there to hold it. See if I can do this one-handed. And then you can see it's actually kind of a nice cab interior there. So while I thought I had everything fixed up on the bench here with this engine, it ran nice and responded well. Brought it out to my layout, and then it acted like the antenna was disconnected. So I have it back in the shop. I also found more burnt out LEDs. I mean, some of the number boards were burnt out. And so this will be my improved number board lighting scheme. Got the 3mm LEDs here. I put another 1K resistor in series. These already have, I believe, 1K resistors in there. And I also put a diode just to avoid reverse biasing these things. They are going across track power, so they're going to be across about 18 volts AC. So here's a better view of Third Rail's LED lighting. It's kind of nice they did everything with these 3mm LEDs. And they just kind of hot glued them in here, although there's molded receptacles to kind of hold them in place, if you can see here. And they just kind of friction fit in there, so I'm not going to put any glue back in there. I don't know, but this is what they did. They only used a 1K resistor, and they're kind of running the LEDs in parallel off of it. So there's no reverse bias protection. I always just think that's a good idea. You know, a 1N 4001 diode. They made trillions of these. Just put one in, you know. I don't know if this was my engine, I'd probably be inclined to pull out all the lighting. I'm not a big fan of marker lights, class lights, overly brightly lit number boards, but I think they'll be a nice guy and fix up my buddy's lighting for him. I'll probably, I don't know. I really want to go bring this back out to the layout and test it though right now, so I might just do that. See if my antenna works. So here we are in the layout, and I'll show you what the issue is. Of course, this thing worked perfectly on the workbench, and I get it out to the layout, all put together, of course, and it just doesn't want to cooperate. So we'll put on track power here, and then we'll fire up the engine. So what I'm showing here is the fact that the engine, when it gets to my layout, the engine decides it doesn't want to respond to anything. After a few seconds, it seems like it warms up and then we lose control. So what I'm trying to display here is the fact that the engine gets on the layout, you can get it started, and then within a few seconds it just starts acting up, quits responding, the headlights flash. The class lights kind of alternate with them because the headlights and the class lights are wired both to the outputs of the R4LC. And what I'm trying to set this up for is to explain what's going on. As you can see, I'm trying to send some commands to it, and it's just kind of sitting there mocking me. So the only difference between the workbench and my layout is maybe, you know, I've got full 18 volts to the track, and the workbench, you know, I can maybe get 15, 16 volts to it. So something must be warming up. And my suspicion, after playing around after a while, was that the R4LC is not happy about something. So in this next segment, I'll show you how I came to determine what the issue was. So here's our R4LC, which is, you know, Lionel's radio receiver decoder board. So it's got some programmable chips on here for the code. It's got, next to this header, you can see there's a line of triacs, and these run the front and rear couplers and the front and rear lights. There's this big triac here is for driving the smoke unit or whatever you have connected that's controlled by the aux189 feature code. And then you can see here, I think there's a little 5 volt regulator kind of tucked in there, you know. So, interesting thing about this, not only does it, you know, receive the antenna, decodes the signal, whatever, and then runs all the outputs, and even sends, you know, can send a PWM signal to motor drivers, etc. It also drives serial comm, and it does that through a hard wire. And Lionel's serial comm looks like this a lot. It's serial signal, whatever, run it on this wire, and it's referenced to ground, and it'll plug into things like soundboards. Here's the soundboard like we pointed out before. Some of the older engines, I think some of the early Odyssey engines, it went, you know, to the DC DRS board. They could hook it up to like that ACRG board they used to use for some of their smoke units. I think it also connects to the smart smoke units, the different versions they made. But anyway, how I found out that this thing was not up to snuff was I disconnected the sounds, and I could get the engine to run forward and backward. Never lost control or nothing. It was great, and I'll demo this in a second. I'll just yank this right out. I'll show you. This can just hang loose and plug this back in and demo it. So here's the engine now with that soundboard disconnected. So you can see the headlight looks pretty happy. And being that it is connected to, you know, one of the R4LC light outputs, you know, it's going to let you know if the signal's messed up. That was the classic mode. So, yeah, excuse all the bumping around and stuff. You know, the shell's kind of loose right now. But I'll just show you. This thing is fully responsive. It's pretty happy. So, that was the clue. And I'll show you what I did to fully cure it. So I had to re-record the narration on this part because I did run sound and it kind of drowned me out. But in this section, I'm showing that I took the R4LC out and I replaced it with an R2LC from my stash, which functionally they're the same, but the R2LC is a known good one from my stash, and I'm trying to show that everything works now. Even driving the sound, we're not in a failure mode. And my suspicion is some of these R4LCs, the component spec is just like right on the edge. And if they're in the upper threshold of where they're supposed to be operating, they tend to fail. So I've had a few R4LCs lately that seem to be kind of flaky, and I suspect that it's probably the component spec or something on them. So I have a known good receiver in here, and we're going to run with it. So I'll show you in this next section another clue I had about serial comm issues from some boards I found in my archives. So I'll show you that here in a minute. So here's something I found in my stash. It's an electric railroad soundboard with kind of a serial comm booster hooked up to it. And you see there's a power wires going into the lower right hand corner, and the upper left is the serial line. And the that little transistor I'm holding there, that's a 2N2222. I think it's an NPN. So the serial comm from the R4LC is brought into the base, and then you bring VCC, I think, into the collector, and then the serial comm out comes out of the emitter and goes into the soundboard. And that VCC line, that's that little red wire that's clipped off there, it was probably hooked up to a little power supply buried in the engine somewhere, probably like 5 to 12 volts DC. And that was just used as a way to boost the signal, and the R4LC or R2LC, whatever was being used, wouldn't have to put out as much current to drive that serial comm, and it wouldn't put it in a state where it was either unresponsive or you lost you'd like control of sounds or whatever. And this is kind of an old thing from when we started doing TMCC upgrades, like, I don't know, 15, 18 years ago. You'd find out this sort of stuff, that the trying to run an IR tether or, a soundboard and all this other stuff, it would really drag down Lionel's serial line there. So this was a little trick to kind of boost it. So I'm pretty tired of looking at this engine on my bench, and I'm glad it's all back together now. So in the next few segments here, I'm gonna cruise it on my layout and call it good.